It's getting late in the day, but I'm just going to try to understand what's going on. So this is the HFKit. I had the original bisected bifilar winding. I tested it. I looked at the SWR. It was ramping up from basically 0 to 4 over the HF bands. I thought that can't be right. So then I rebuilt it with the same hardware, but I swapped out a homemade Guanella 1-to-1 balun, traditional resistors style overlap winding, and got a similar kind of crazy SWR ramp from 1 to 3 or thereabouts. And it struck me that I'm perhaps measuring it in the wrong way. The balun is designed to balance currents on the outputs, and so you insert something in the input, and then you should get balanced currents on the output. So that's what we're going to try to measure. So I have the two outputs. I'm feeding in some RF. I've loaded these outputs with each has a 25 ohm resistor load. So there's a bunch of resistors making 25 ohms here, 25 ohms here, and everything is grounded at the middle point. So basically these two circuits that are circulating are passing RF and current through these resistors. These are high precision resistors to ground. And this is the setup. So I have two channels. So I'm pumping in 14 megahertz, and I get channel 1, a nice sine wave. I can do this on camera here. We have channel 2, another sine wave. And if we put them together, we'll see that they are 180 degrees out of phase, or thereabouts, right? Very nicely out of phase. The amplitudes are slightly different. And in fact, if we just change the settings here, so I'm just increasing the zoom in on the divisions of the scope, and I hit add, and I'm inverting the second channel. So this is the difference between those two channels. And I calculate basically, if we zoom it over here, it's kind of 1, 2, 3 ticks, or 2, 4, 6, 8, 10, so 6, let's call it 6 ticks on a division. And if that division is 20 millivolts, that's 6 times 2 is 12 millivolts of difference in the voltage measured at the outputs. 1.2 millivolts. For a 1 volt peak-to-peak input, I'm getting 12 millivolts difference, which is 1.2% error in terms of balancing the currents, because we are measuring currents, because when you measure the voltage to ground through a resistor, that's the constant proportionality. The current is proportional to the voltage across the resistor. That's Ohm's law. So a proxy for measuring the difference in the current at the balun outputs is on the order of 1.2%. That's pretty good, right? So, and I think that that holds true even if we go down, say, 40 meters. In fact, it's a bit messy down here. It's kind of interesting, but again, it's 6 ticks at, what are we on? 10 millivolts, so 6 millivolts of error in there somewhere. So it's getting better with the lower frequencies. The balance is better. But again, for a 1 volt peak to peak, the difference in the currents is millivolts, which is nothing. So actually, I think the balun's probably okay. SWR is not the way to look at it. You really should look at measuring the difference in the current outputs. And I think that is doing the right job. So now I have a decision whether to keep this turning toroidal wrapping, which I guess is okay for now, stick it up and see what happens. And if I want to drive higher power, I'll probably strip it out and rewrap it with some other designs. There we go. So